In this tutorial, let's take a look at how we can create a melting geometry type of simulation. Let's take this cup, and the scale and rotation have been applied. And let's just check for manifold geometry. So there are no manifold edges. So let's move ahead to the RBDLab add-on. And let's fracture this geometry using standard scatter. Before we fracture, let's take a look at the geometry. So this is the geometry for this glass. And let's add a standard scatter. And let's increase the density to something like 500. And let's accept and fracture. It takes a bit more time for the fracture as the geometry is a little bit more dense. Let's click on Auto Smooth. And there are a few chunks which are bad. So we can either select these chunks and in pre-selection, select bad chunks and then auto fix. But if it's a simple geometry, what I'd like to do is I'd like to select all the chunks and select bad chunks, just in case if we miss any of the other chunks. And the rest of the chunks seem to be fine. So let's apply the fracture. Looks good. Now let's head to the physics tab. Let's add a ground and toggle the visibility. And let's head to RBD. And let's click on MetalSoft and add rigid bodies. And let's head to the constraints. And under constraints, let's select between chunks and the type as soft constraints. And with the source filter as this collection, let's create constraint group. And under limit linear distance, let's toggle the XYZ and change the distance to 0.05 meters. And spring angle, stiffness, let's reduce this to 0.1. And then damping, also let's reduce this to 0.1. And let's do the same thing on the spring linear. And update. All right. Now let's head to the activators module and let's select all of these chunks by selecting a chunk and clicking on select color. So that selects all the chunks of the same color. And under source is the target collection, which is this target collection, and the layer type as dynamic. Let's add layer. All the chunks have changed color to indicate that a layer has been formed. Now, when we play the animation, there's no dynamics because there's no activator here. And the dynamic animations are set to start off and actions when activated on. As there are no activators yet, there's no simulation happening. All right, so let's add an activator. Let's add a cube activator. And let's scale it down in the Z direction. And let's move it up in the Z axis. And at frame 1, let's insert a keyframe for the location. And let's go to frame 250. Let's move it down a bit and insert a keyframe for the location. And let's change the interpolation mode to linear. So as the activator moves down, we would like these chunks to be activated. Looks good. So now with the dynamic animations as start off and actions when activated set to on, and let's use single activation as we want every chunk to be activated only once. And with the margin set to 0.1 so that only few chunks are activated which are close to the activator. Let's hit record. All right, let's take a look. And there we go. As the chunks are being activated, due to the soft constraints, the chunks start falling in a melting fashion. Looks good. Now let's head to the MetalSoft module. And here, let's create Mesh Deform. Since we fractured using the original mesh, we can just click on Create Mesh Deform. And there we go. So this is going to bind the original mesh to the fracture chunks. Now, as we can see, we need to increase the resolution. So what we can do is we can add a subsurf modifier and increase the levels. There we go. So that's how we create melting geometry, sort of a simulation.